Hello, welcome to our Gentoo installations video. First, what is Gentoo? Gentoo is just like any other Linux distribution, except that it is not one size fits all kind of distribution. It is known for extreme configurability and modularity. It is definitely not a beginner friendly distribution. We can download Gentoo based on our system architecture from the official Gentoo website. They have multiple images and stage files. After that, let us try to install Gentoo on a Raspberry Pi Zero with headless method. First, we have mounted our SD card onto which we will cross-compile our Gentoo installation. We are wiping our SD card here. And after completely wiping our SD card, we will use fdisk to make our necessary partitions. The syntax to make a new partition is to give p, and then we select our partition by giving a number. After selecting the partition, it all defaults to the first sector available, and then we give the number of sectors that we wanted to have. There are lots of online sector calculation with the megabytes of data. In our case, we have given the number of sectors as 250,000, which will equate to around 120 MB that we intend to make as our boot partition. After that, we made a 1 gigabyte swap partition, and the rest of it we gave it as root partition. After making our partitions, let us go and use the mkfs command to format them. So SDC1 is going to be our boot partition in this case, and SDC3 is going to be our root partition. It is taking a little bit of time. After that, we will go and assign the swap partition to SDC2. Now, I'm making a directory called a rasp so that I can download all my Gentoo files onto this folder. I can use the wget-c command to get the sources, but I think it's better to just go into a browser and download these. Yes, I have successfully downloaded the portage and the stage 3 file that I require. I am creating directories called /mnt/gentoo, and I will extract the stage 3 file into Gentoo. Copy paste did not work, so I will go into the downloads folder. As I did not wget and I downloaded the source file, so they went into my downloads folder. So now I'll use the tar command to extract it. I have to extract into /mnt/gentoo. In the similar way, I have to extract the portage file into Gentoo user. The respective partitions are also mounted onto these folders, as in the /mnt/gentoo has a root partition. Now I have to go ahead and git clone our Raspberry compiler. GitHub has recently disabled no HTTP requests, so I have to replace the git with HTTPS here. And yes, I finally completely got it. Now I'll go ahead and link it to a different folder that I need. Here, now I can make the bcmra defconfig. Looks like it needs a few dependencies like flex and snap. Let me install flex. Then it's asking for bison. Let me install bison. Yes, after all of that, I was able to successfully make the config. But now to go and cross compile, I also need the GCC libraries, which is what I'm trying to install here. Feel free to pause at any time of the video if it speeds up a little. Yes, now I will try to cross compile this. I've made the bcrmi config file earlier. This is where we kept on facing a lot of issues because the file naming architecture and the folder architecture is quite different as what the compiling software is expecting us to give. So there are a lot of broken links which are highlighted in red here in the ARMv6j hard FP folder that we downloaded. And fixing broken links isn't a thing. We have to delete all the links and create new ones. But these are just way too many numerous links that we cannot individually create. So I have tried to fix the folder architecture so that I place it in a particular way where it automatically accepts it. So I've tried multiple things to fix this issue. After struggling with it for quite some time, we were able to fix the link broken issue. We went and inspected the targets of a lot of these files and made sure the source files for these links are readily available in their targets. It is going for this folder called user slash arm linux gnu ABI. With the folder replaced, all the links are now showing as in white color with their targets perfectly installed. Now we've tried and compile old config, but we ran into a unknown compiler error, which we were not able to fix even after struggling on it for quite some time. The old config is used because the kernel configuration options are added and removed with each kernel release. So the old config is used to smooth out the differences and make any relatively new configurations compatible with the current version. After that, instead of going with the Linux stage 3, we just went and gave it out the default ARM Linux GNU ABI which we had, and we were able to compile it. Then we gave -J2 because ours is a 2-core processor. We can give J6 if we have 6 cores and 8 if we had 8 cores. After that, we initiated the final compilation, which needs a few more dependencies. We identified what the dependencies are. Particularly, we are getting an error with OpenSSL here. Going ahead and installing all the dependencies. /bin sh bc not one. So we can go ahead and install bc. Now we've initiated the compilation. This would take around 40 minutes. So let me speed up the process. After the J2 compilation is done, we must now be able to move all of this compiled pieces of files onto the Gentoo folder. We used that command before, so going back and copy pasting from there, correcting the folder names, and then we would initiate it. Once initiated, it would take anywhere between 10 to 15 minutes again. This particular make error can be ignored. It isn't that big of a deal. From now, we can go ahead and edit the menu config files, for which we can give the command make menu config. This is the Kali's kernel configuration setup. This isn't particularly useful for us. We have mistakenly gotten into this with that command, but for the Raspberry Pi, we have a different thing. Going back, let us verify all the files that we have compiled and installed until now. And we should find the make.conf file in one of these folders, which we have to edit to go ahead with the process. So it must be in the portage folder. Yes. So in this, within some Gentoo forums, we were able to find a few specific changes that we need to make for Raspberry Pi to be running Gentoo. Let me copy paste all those details here. It specifies a lot of parameters about our installation, the where our port directory, mentioning it as slash user portage, our current Gentoo mirror that we are using. Hmm. Yes, after editing the make.conf file, now we have to go and give it a proper time zone. Here we are giving the Europe Paris time zone. It is quite a straightforward method to do it. That is it. So this would select the Paris time zone for our Raspberry Pi when booted. After which, this is the process of selecting the boot order for our device. So we have to give the partition name here, or the disk partition name that we made for it is SDC 1, 2, and 3 for us. So R1 is boot, R3 is root, and the 2 is our swap partition. We have to mention it similarly in this fs tab file. Yes, running fdisk to see everything is all right. It is. Now we have to go get Raspberry Pi's firmware from GitHub. Again, GitHub needs HTTPS links now. Git semicolon doesn't work anymore. With the firmware now downloaded, we can compile this onto the SD card, which would automatically work in the Pi. We are now installing the Chemo ARM. There are multiple packages within Chemo ARM. Each one of them is specific in itself, and we need different types of these to complete the installation. In this case, I think we can simply get the Chemo system ARM from the directories. We also got the apt got it the Chemo user static K parts. Yet we still have a few more dependencies to go. Now we have to finally mount the Gentoo sys folder. Getting into chroot, which means our Kali is now acting as the root for this cross-compiled system. We can see that it is saying ARM v7L, which is being run by Ryzen 5 5500U. So ARM v7L is the supposed architecture for the Raspberry Pi, and Ryzen 5 5500U is our local CPU here. We will be able to boot from here. After that, when we put the SD card into the Raspberry Pi, it is detecting that an operating system exists, but we were not able to successfully boot or assign any network addresses within the headless install. No network address means no SSH either. We faced too many issues post this step, and
we are supposed to get ARMv6J, but instead it is keeping on showing ARM7L, which is not the correct architecture for our lower end Raspberry Pi Zero. ARM7L goes for Raspberry Pi 3 and higher, which is why the detection of operating system worked in the Raspberry Pi when the green light is highlighting, but it isn't exactly booting up or doing anything. This is a definitely good attempt and a nice learning experience about cross compilations. But the Gentoo installation, we fall back to a regular VMware based installation post this. Thank you.